All right, thanks for coming. I'm Jesse. I work on infrastructure at Layer. And so why are we using CoreOS? We picked it because it's small. Louder? Can you hear me now? All right, so we picked CoreOS because it's small and it's simple, but it still had a surprising amount of surface area. So I want to go through some of the things we learned along the way. Some of these are things that we're pretty sure we got right. Some of them are just a collection of what seems to be mostly tribal knowledge that we've collected along the way, and other things you'll find to be things in flight that, because CoreOS is evolving quickly, they may not apply 3 to 6 months from now. So one of the things we do with every CoreOS host we deploy is our cloud config specifies a deployment container. The deployment container is a one-shot service. Its purpose is to drop some missing tools onto the host and then exit. There are a couple of different ways you could achieve this, but this seemed to be the pattern that worked best for us. The obvious option is using a fleet global unit. The problem with that is, at least in the current state of things, you don't have rolling deploys. We wanted to have per host control over this. So these are the sort of things we're dropping in on there, right? Every host, we end up using confd. You need JQ. JQ makes your life a whole lot easier on CoreOS. You guys should maybe, you got my vote to put it in. And then a few helper scripts for Docker. Docker ID and Docker IP do about what you think they do, just so you don't have to remember the magic Go template to pull those out. That's an example of one of them. So service discovery, everyone's favorite topic. Of course, we're using etcd for that. That's one of the main reasons we're using CoreOS. And it's helpful to talk about the different parts of service discovery. So think of it as service registration, which happens when a service comes up and says, hi, I'm here. This is my name, and these are the ports that I'd like to advertise. And then there's service discovery, which service comes up and says, OK, these are the services I'd like to talk to. Help me find them. Where are they? And then there's a bit of glue in the middle, which is a service healthy, and should it remain in the service pool? Which isn't absolutely necessary to the concept, but it helps to have it in there. So this is about what our service registration looks like. I apologize if you can't see it in the back or hear me in the back. But so it's a little bash script that exists in our base Docker container. And all it does is look for a JSON file in a certain location and say, hey, if you're there, I'm going to submit you. So we're saying, this is my container ID. This is my name. These are the ports I'd like to advertise. Please start checking my health, and if I'm healthy, put me into the pool. So this is an example of a file that a Leaf service would actually have in there. This is Nginx. It says, I want to have an HTTPS service. I want to have an HTTP service. And there's a third port named health, which must be part of every service we deploy. And the rule there is the watchdog on every host, once a second, checks the health port, and you're required to respond to an HTTP call, an HTTP GET, with 200 if you're healthy, 503 or something else if you're not healthy. If you respond not healthy, you'll be yanked from the pool. One of the reasons that it's helpful to have this, rather than just directly registering and then appearing somewhere in the pool, is if you'd like to drain traffic from a service, you can have it mark itself as unhealthy, let new traffic go away, and then start your shutdown sequence. So you have a clean upgrade. So this is what the other side looks like. After the watchdog service has decided you're healthy, it puts you into the pool's key space. So this is under v2 keys in etcd. And the way to read this is, in pools, there's a service named Layer Nginx. It's running at version 1.0.0, and here's its Docker ID. The Docker ID is really just there for uniqueness. Downstream services may or may not care about the version. If you don't care, you just recurse over the whole namespace and grab all the instances of the service. And worth noting is that the HTTP and HTTPS ports in here may or may not match the one the service requested. When the service registered itself into etcd, it said, OK, I'm running daemons that are listening on these ports inside the container. These are the ports that the watchdog actually mapped from the host. New topic, fleet global units. These are pretty new. They're already really useful for us. But there's only a certain type of per host service that you can use them for at this point, or I should say that it's convenient to use them for. Since if you want rolling deploys, you have to roll your own. So the services we use those for are log collection and metrics collection. Because we don't really, those are the types of services where we can say, OK, if we need to make a change, upgrade it, we can upgrade all log collection or all metrics collection services at once. It's low risk. So the examples there are on every host, they're inside a container. There's collectd and cAdvisor running. When they come up, they find a Graphite instance via service discovery and start sending it data. That Graphite instance might move around. They'll follow it. Same applies to logs. There's a global rsyslog service running on every host. It's got the journald file system mounted in, follows along with everything written there, and then forwards it to an Elasticsearch node running somewhere in the cluster. So one of the things we found is that first approaching CoreOS, it seemed like Docker and CoreOS were mostly orthogonal, that, OK, you have Docker containers, you drop them into CoreOS. What we found over time is that things get a lot cleaner and smaller if you're willing to bake some assumptions about CoreOS into your Docker base image. In particular, bake the assumption that there's always an etcd running on your parent host. Another of the optimizations we made is that we're careful about the way we build containers. So this is roughly what our base image looks like. And it may be a little hard to see in the back, but the point is that there's just one run command, and that after you do an apt-get install of whatever you're going to install, you clean up after yourself. If you don't do it that way, you could have the same thing, but with multiple run commands, and you'd end up with a much bigger end result image. And the reason for that is you download a file, cut a container, remove the file, cut a container. At the end of the day, you're still carrying the weight of the files you deleted, which is unfortunate. And it doesn't really matter in production. If your total Docker image size in production is 1 GB versus 4 GB, you're really not going to notice. Where you really care is when you're downloading all of these onto a Vagrant instance, and you're at home on cable internet and not at the office. All of a sudden, you cared that your images are not bigger than they need to be. So what are we using? Fusion's base image Docker. We disable all the built-in daemons. We're really just using it for run it. The reason we care about run it is it gives us that nice supervision tree. And a common pattern that we've come to in our containers is the primary daemon running the service is kept alive under one directory in etc service. And then something like confd is running alongside it, doing service discovery periodically and sig hupping or whatever the appropriate mechanism for that service is to say, hey, you have new upstream services, refresh yourself. New topic, Docker image tagging. We tried more complicated ways of doing this, went through a few iterations, and arrived at the simplest answer, which is map your Git repositories one-to-one with your Docker repositories, and then map all your Git commits, Git branches, and Git tags one-to-one with Docker tags. That way, when you have a Docker image deployed on a system somewhere, you can instantly find it in source control. So the way we build those are that the workflow as a developer is do your local development, preferably in Vagrant, in a CoreOS image, in a container. Test your changes, push them off. GitHub pushes that commit to Jenkins. Jenkins says, OK, this has a Docker file in it. I know what to do here. Build my image. Run your post image, your post build tests if you put them in there. So it'll look for a script in a certain location that says, OK, you have a final build artifact. Run these tests on the final artifact. Only if those pass, push it to the registry. End result, every commit, every branch is pushed to the registry as long as it built successfully. And tagging is a manual operation. You have to say, I'm releasing, I want to create a release artifact, probably for production. And the tool looks just like that. If layer Cassandra is the name of the repository you're interested in, you're saying, I want version 302 at this commit. As long as there exists both a Git commit and a Docker tag that match that hash, it'll happen. And deployment looks very similar. So whether you've built it automatically through Jenkins or whether you requested a tag, you say, deploy this service, this Docker tag to this target. The target could be Vagrant. The target could be an IP address belonging to a cluster. Doesn't matter what node in the cluster, you deploy it there, and it follows the normal fleet metadata rules. So a couple important things to note there. Those bottom three, they could be all the same thing, right? 302 master and that commit could actually be exactly the same thing. And then deploying to Vagrant looks exactly the same as deploying to a cluster, which is what you want, right? That's kind of the point. OK, so now we've built up our Docker tags, and we want to template a unit file or a service file and push it to a cluster somewhere. Over the life of a service, some things are going to change, some things are going to stay the same, right? Let's say we're deploying our Cassandra service. Most things will stay the same. What will change are the tag, the index. Index is a numeric index of the service. So this is instance 5 of whatever it is I'm deploying. Host group is, so when we create a cluster, we name it something like stage 1-ops-1. And that means I'm the stage 1 cluster. I belong to the ops host group, and I'm instance 1 of that machine. So when you deploy a service, it's got a fleet metadata that says, OK, only deploy on this host group, right? So there's a DB class of machines. There's a web class of machines. There are ops machines. Ops are all your Graphite, Elasticsearch. And then because you're running multiple instances of a service, upgrading one just says, OK, index 2 is now going to move to this version. Take it out of the pool, let traffic go away, shut down, replace the unit file with this new one that I've templated that has an updated version, bring it up. It'll come back up into the pool. You can't see that at all from the back. I'm just going to point out that part of that templating is setting some environment variables, which if we go back to the very beginning at our service registration script, it expects these to be there. So if we look at it again, we see, oh, OK, this is where it got the service pool and the version to put in there. So we've built that service, we've tagged it, we've deployed it. Now we want to know if it's running and healthy. This is the watchdog service I was talking about before, small in the back. But what you're seeing here is, OK, there's a service named layer Cassandra. This is the version it's running at. These are the ports that are mapped. And this is how long it's been alive and healthy for. That's how you look at it on individual hosts. Now you've got this cluster of machines all running this layer watchdog service. And each of them exposes its internal information via JSON interface so that we can wrap it all up into one interface, right? Where we say, OK, these are the services running on what node. They're healthy now, or something went wrong. They're down. Let's go find out why they're down. So our lessons learned. Deployment container to ship our missing tools, that falls into the class of good right now, but maybe a temporary solution. We're not sure if that's exactly right. I wouldn't change it for anything else right now, but as, for example, fleet global units, if they gain the ability to do rolling deploys, maybe something like this doesn't make sense anymore. Using tags to map source and builds to deployment, that we have right and is unlikely to change. The model is too simple. You really want to map your Git repos to your Docker repos one-to-one, so you can always figure out where something came from. The rest of building, so the way we've got the base image set up feels just right, particularly doing service registration there. It feels right to, in an individual Leaf service, say, this is my JSON file. It's small. It says what ports I'd like to advertise. That's it. I don't have to know anything more about how service registration works. That part feels right. And then high-level takeaways that there are a lot of service discovery tools out there. Many of them try to solve the whole problem. I don't know if that's right or not. What we found is that service discovery is a concept that we had to bake into our way of doing things pretty deeply to get it to work in a way that made sense for us. That's it. Questions?
How are you storing your containers? Do you run registry using the Dark Hub?
So we actually spin up a one-node CoreOS cluster in Google Cloud, backed by their cloud storage.
Cool. You're happy with that?
So far, it works.
Was there any reason that you spun up CAdvisor via a fleet global unit rather than just directly embedding cloud config?
Yes. The reason we did that is because, well, so one, I don't really like running CAdvisor directly at all. I think it's a great demo way to drop it in and get quick graphs of Docker containers running in there. But what I'd really like to do is rework it so that we're using the APIs they're using, call them directly for only the C groups we care about, rather than polling all the C groups in the whole system every time. So it was a low-cost way to do the temporary thing.
Okay.
How's your experience been running etcd in production?
etcd has been fine. You have to get up to 0.46 and get past that memory leak that was in there earlier. But once you're past that, it's been fine.
Have you had to deploy a separate cluster, or is it running everywhere in your infrastructure?
etcd, it runs on every host. All right, thanks, guys.